This chapter is on haloalkanes, sometimes called alkyl halides. Haloalkanes are sp3 carbons that have a halogen on them like the compound below. The carbon, it protrudes an sp3 lobe, and that binds with one of the lobes of the halogen to make a sigma bond. How to name these? Just like we've done before, except for instead of only having methyl, ethyl, propyl, isopropyl substituents like that for the alkyl, we're going to call these fluoro, chloro, bromo, and iodo. Otherwise, everything else is the same. There are some common names that you will hear throughout the course of the semester. These are not so important. I'd much rather you focus on the systematic names. So dichloromethane for the first one at the left is sometimes called methylene chloride. Trichloromethane is sometimes called chloroform, etc. You don't need to know the common names, but know how to name these using IUPAC system. Freons were very widely used in the past, and we still have some analogs of these that are less dangerous. So the ones that have been taken out of circulation are Freon 11 and Freon 12, and these are compounds composed of only carbon, chlorine, and fluorine. So only carbon and halogens. And now we're using the ones at the bottom that are shown there, HFC134A, for example. And both of these, you'll note, have hydrogens on them. So you should give some thought as to why hydrogens are important in these and why they're less dangerous than the chlorofluorocarbons above. There are two main kinds of reactions we're going to talk about in this chapter of alkyl halides, and those are nucleophilic substitution and elimination. And so the elimination is called specifically beta elimination. But nucleophilic substitution, this occurs at the carbon with the halogen. So the nucleophile, which is a Lewis base, something donating electrons, comes in and makes a bond to the carbon that bears the halogen, and the halogen comes off. And so those are shown in the two red arrows at the bottom left. Nucleophile comes in, halogen comes off, and we end up with a substitution product, as you could see at the top right, when we use as the nucleophile ethoxide, sodium ethoxide. So that's a nucleophile and a base. In this particular case, it's adding like a nucleophile rather, and it's doing a substitution. In the bottom example in blue, bottom left, the ethoxide can act like a base and pull off that proton, and the pair of electrons that binds the carbon with the proton, that pair of electrons becomes a pi bond. And in order to not violate the octet rule, the bromide has to come off as Br minus. And so the blue arrows show it happens with a beta elimination, but we go from an alkyl halide to an alkene. So in the top reaction, the substitution reaction, we substituted the halogen for a nucleophile. In the bottom one, we had a base that pulled off a proton. By the way, it didn't pull off the proton on the same carbon as the halogen, it pulled it off on the beta carbon. So we pulled off that proton so we can migrate the electrons to make a pi bond and to kick out the halogen. These are the two main reactions for this chapter.